We'll talk about the reflection and refraction. 一个是反射，一个是折射。那可能高中物理的光学应该会有学过，或者初中物理的话，应该我不确定，因为我是初中有学过这个光学的。So actually the law of reflection is as simple as the input, the angle of incidence equals to the angle of reflection. OK， 就是反射角等于入射角，就这么简单。OK， so actually it's like we have two material, and then suppose part of the light can be reflected, and then we will draw a normal line here, and then the incident and refracted angle is count from the normal to the incident wave or the refracted wave. So it's nothing but a theta 1 prime equals theta 1. Okay, nothing special. Okay, and then here is the law of refraction. Okay, 就是折射的定律，叫做 Snell's law. Snell's law. Okay, a refracted ray lies in the plane of incident and has an angle of refraction theta 2 that is related to the angle of incident theta 1 by this one. Okay, I suppose in high school, you should have learned this. Okay, so N1, N2 are the dimensionless constant called the index of refraction. Okay, that is associated with the medium involved in the refraction. Okay， 所以就是跟这个 N1 跟 N2 就是跟那个物质有关，就是比如说空气真空的话是1，那如果其他物质的话，这个 index of refraction 就会比1来的大啊，没有会比1来的小的，因为如果比1来的小的话，等于说那个光束在那个物质里面是超越这个3乘以4的8次方是目前是没有的。Okay, so so it is nothing but n1 times theta 1 times theta 1 equals n2 times our theta 2. Okay, so here we talk about another property called the chromatic dispersion. Chromatic dispersion， 中文叫做色散。OK， 光的色散。OK，chromatic dispersion of white light 就是白光的色散。OK， the blue component is bent more than red component。这里的红跟蓝不是真的指红色而已，或者蓝色而已。这里的红跟蓝是指说这个是 lambda 比较大的 ，lambda is large. Okay, refer to the I mean longer. The lambda is longer. Okay, longer wavelength. Okay, 就是波长比较长的。Okay, the blue refer to the shorter lambda. Okay, shorter lambda. 就是一个是指长的波长，一个是指短的波长。Okay, so the blue component is bent more than the red component. 所以，如果真的要看的话，这个折射的角度，蓝色或者是短波长的话，会折的比较多。折的比较多是怎么算的 ？Okay, so here is the incident light. Okay, of course, some of it will be reflected, by this interface, and then so this is a reflected light, and then some of the light will be reflected. Okay, if we don't consider the dispersion, okay, we just consider a single reflected wave beam. Okay, but here, just for exaggeration, 就是这个是夸张的，实际上那个色散没那么夸张，那我们怎么说它的角度比较大的意思是我们延长这个入射线，就是这个虚线的地方。那 这个会比这个来的小啊，我们就说这个蓝的偏转比较厉害。So we will say according to this angle for the blue ray is larger than the angle for the red ray. So we will say the blue component is bent more than the red component. Okay, passing from the air to glass, the blue component ends up with the smaller angle of refraction. OK， 反过来也一样的，反过来的话，你可以看成是这样啊，所以红的角度也是偏转的比较少的。Okay, passing from the glass to air, the blue component ends up with the greater angle of refraction. Each dotted line represents the direction. 不用管它。OK， 所以这个有这个特性的话，所以我们会用红色的灯去当红绿灯的红灯啊。它不单纯是漂亮或者是怎么样的，就是红绿灯为什么红灯要红色，绿灯要绿色，或者是说红色要停，绿色要走啊，可不可以其他颜色？那它的原因跟这个有关，就是说这个红色的偏转比较少，所以如果比如说在潮湿或者是下雨的天气的话，那这个红色的光相对会比绿色或者蓝色能够传得更远的距离，所以很大雾的，你可能前面看到有灯那在一个适当的距离的话，你也许只看到红色灯，就看不到其他颜色的灯就算它们同时亮起来的话就是红色能够传的距离会更远一些。当然，如果真的很浓的话，在更远的距离，也许你全部都看不到，但是至少红灯能传得远一些就是比如说像车尾灯啊，就是你如果会开车有驾照的话，你知道你踩刹车的话，车尾的是亮红灯的所以你至少是一个比较远的距离能够看到一个红灯在亮那你就知道前面在减速，或者是前面的红绿灯是红灯那我要停这样。那如果你能够走的话，你看不到，因为反正你就维持着动嘛，所以如果你比较近才能看到的话，相对没那么严重但是你如果要停的话，那能够反应的距离大一些会更好。Okay, so here we talk about the total internal refraction. So I suppose you also learned it in high school optics. 就是说，它如果从一个光密的介质，就比如说像从水进入到空气，进入到一个光束的介质的话，那它的折射角会变大嘛。所以如果它的入射角如果足够大的话，那个折射角已经90度那这个叫做 critical angle。那这个入射角叫做 critical angle。So this theta c, okay, so for this theta c of the incident ray, okay, for example from this glass, okay, from the glass to air, okay, so for this theta c the refracted angle will be 90 degrees. So this angle is called the critical angle. So if the incident angle is further larger than theta c, then all the ray will be refracted. There will be no refracted ray because this angle can be larger than the refracted angle can be larger than 90 degrees. Okay, so or there will be no solution. There will be no solution. So it is like you have a n1 sine of theta 1 equals n2 sine of theta 2. Okay, so suppose here n1 is larger than n2 is larger than n2. So here we would like to find theta 2. So sine of theta 2 will be n1 over n2 sine of theta c. Okay, sine of theta c. Okay, no, sine of theta 1, sine of theta 1. Sine of theta 1 first. Okay, so which means when is, so I mean what is theta c? What is theta c? Theta c means sine of theta 2 is 1, okay? When sine of theta 2 equals 1, okay, so theta 1 equals theta c. So which means theta c will be arcsine of n2 over n1, n2 over n1, like this. Okay, so which means if theta 1 is larger than theta c, okay, let's say if theta 1 is larger than theta c, so if theta 1 is larger than theta c and is smaller than pi over 2, in this case, sine of theta 1, let's say sine of theta 1 prime, okay, sine of theta 1 prime will be larger than n2 over n1, larger than n2 over n1, okay. 因为这个 sine 的话，在0到90度之间是增加的啊，是 increasing 的。So in that case, it will be larger than n1 over n2 times n2 over n1, okay, which is equal to 1. Okay, so in that case, sine of theta 2 is larger than 1. Okay, we cannot find any solution for the theta 2. So there will be no solution. This is the condition for the total internal reflection. OK， 所以全部都会反射哈，所以中文叫做全反射。Okay, but here there are some interesting stuff here, so which is called the frustrated total internal reflection. 我中文我不知道什么，反正 frustrated 中文叫做沮丧嘛。但是你知道沮丧的全反射好像很奇怪，但是这个什么意思 ？So here it says as this is actually out of the textbook. Okay, so I find it here. Okay, so it says a 45-90 beam. Okay, 它是一个45度90度的棱镜有两个。Okay, we diffract a beam of light by total internal reflection. When two such beams are sandwiched back to back and pressed together, the air glass interface can be made to vanish, and the beam then propagate onwards and distribute. 什么意思？就是说这个折射率蛮大的，所以如果它们是分开，这两个是分开的话，这两个是分开一定的距离的话，那这个入射进来的话，全部都会反射它会 theta 1大于 theta c 了，这个 case 是theta 1大于 theta c， 那所以是全反射的状态。如果这里是说，如果我们把两个是压在一起，它中间一点缝隙都没有的话，那全部都会通过，因为这个界面的话就不存在，这个不存在。So this is no reflection here if we press them close together. Then it will propagate onward and distribute undisturbed. I mean, 就没有被干扰的去传播。Okay, this transition from total to no reflection occurs gradually as the air film is made to thin out by progressively squeezing the films together harder until they make intimate contact. 所以物理学家就很无聊嘛，这个是全反射，这个没有反射嘛，那我拿在中间怎么样？ Optically speaking, if evanescent wave extend with appreciate amplitude across the rare medium into a nearby medium of high reflection index, okay, energy may flow across the gap. Okay, 所以中间会怎么样？中间的话，你拿一个很窄的缝隙的话，它会有一些反射，有一些可以穿过去，所以的话，如果这个缝隙足够窄的话，它会有一部分穿过去然后这边就冲过去然后一部分的话是反射过来的那这个的话其实是也是一个量子的效应，但这学期也没有学到这个叫做tunneling effect 就量子力学的话叫做 tunneling effect。 tunneling effect， 就是它会穿过去。当然量子力学的那个是另外的，这里简单说一下，反正剩下有时间。它量子力学的这个 tunneling 的意思是，如果在古典力学的话，如果这里有一个 potential， 这里是一个 potential， 这个是一个，比如说是一个空间 x， 那这个是一个很高的一个位能的一个 wall 的一个墙壁一个 potential wall。如果你有一个粒子，你的 kinetic energy 比这个 potential 来的小的话，古典力学的话告诉你，你穿不过去，你就会弹回来，就是好像有一幅墙在那边，你丢一个球，那你的动能不够越过这个墙壁，那球就会弹回来，你过不去。但是在量子的世界当中，它就不是那样的。它如果有一个这个那叫什么 wave function 量子力学叫做 wave function。OK， 它遇到一个比如说这个是这个的 k 这个的动能会比这个 u 或者 v 来的应该用 u 了。这本书的话是用 u 这里的话如果 k 小于 u 的话，它这边它会变成一个驻波，变成一个 standing wave standing wave 变成一个驻波。然后在这里的话，它的几率会 exponential decay， 就是它会衰减。怎么理解这个衰减呢？就是它是有一定的几率可以穿过去，有一定的几率没有穿过去，它就回来跟你入射的形成一个驻波。因为物理有学过吧，就是你一个波过去，一个波回来的话，它们加在一起的话，它就会变成一个驻波嘛。那所以它有一部分反射回来的话，形成驻波；有一部分的话，它的概率一直衰减，就是那个墙壁在那如果那个墙壁没有很厚的话，它能够穿过的几率就会在，但是它会随着这个厚度越厚的话，它的穿过的几率会越来越低。那如果它这里还能够顺利到达这边的话，它这边就会顺利的出去所以这边是驻波，那这边的它就会顺利通过去，有点类似这样应该是差不多的意思。这个叫做 tunneling effect， 其实是可以解出来的，写出那个 Schrödinger's equation 可以解出来的。当然这学期的话就没有去教这个部分，但如果你对物理有兴趣的话，其实可以去看，我有放上来的，就是这个37章跟38章的 slides。对，有放上来的，跟这个怎么去推一些 Schrödinger's equation， 或者是你找到我的 YouTube channel 比较旧的年份的话，是有教这两章。OK， 所以这个是所谓的 frustrated total internal reflection 那个缝隙够窄的话，它可以穿过去。Okay, so here we have table about the reflection indices. So as I mentioned, the vacuum is perfectly perfect one. Okay, because I forgot to mention one point is that for this n is defined by the c over the v in that material. Okay. The wave velocity, in that material, 就是在那种物质里面的那个波的速度就是 v， 那任意的速度都不能超过真空的光速，所以这个 n 一定是大于1的，一定是大于等于1的。 Okay, so going back to here, so for the vacuum, it is nothing but Z over C, and equals C over V here. Okay, so for vacuum, C over C, which is exactly 1, and then for air, it is still very close to 1, but it is 1.00029, okay, a little bit more than 1. Okay, but for water, water is 1.33, 4 over 3, and then grass with heavy thin gas is 1.65, and then for diamond 2.42. OK， 所以女生就喜欢这个钻石嘛，所以就是因为它的这个折射的系数很高，所以它就是看起来很亮的感觉。So for wavelength of 589 nanometer yellow sodium light. OK， 所以光的那个可见光的波长都落在几百个纳米的这个层级几百个纳米。Okay, so finally we talk about this thing called the polarization by reflection. 我们可以透过反射来产生极化光前面的话是用这个 filter 可以产生极化光，这里的话是反射在某一个条件之底下可以有极化光。Okay, so it says a ray of unpolarized light in air is incident on a glass surface at the Brewster angle theta b. OK， 所以这里有一个叫做 Brewster angle 的东西。OK， the electric fields along that ray have been resolved into components perpendicular to the page. OK, the plane of incident, reflection, and refraction. OK, and the component parallel to the page.OK， 所以这个的话是说 incident 就是这个入射线的话是没有极化的，那这个是它传播的方向，然后它有绿色的这个震荡的方向，也有橘色的，就是进入跟就是垂直这个面的方向，两个方向都有，来代表这两个极化的方向。OK， the reflected light consists only of component perpendicular to the page and is thus polarized in that direction. The reflected light consists of the original component parallel to the page, weaker component perpendicular to the page. This light is partially polarized. OK， 所以这个之前有考过final exam 的时候，不确定今年会不会考，因为还没出考卷。所以这里的意思是说，如果这个入射角是这个 Brewster angle， 下面有一个公式，这个 Brewster angle 怎么算的，跟这两个物质的那个 n 有关。如果入射角是完美的 Brewster angle 的话，那反射线就是全部都是橘色这个方向的极化，而这个折射线它没有完全极化，就是它部分极化，就是它绿色方向的话是全部过去，那有部分的橘色也过去，所以产生极化的只有这个反射线，那这个折射线的话是部分的极化。OK， 所以它只有一个 weaker component perpendicular to the page 就是橘色的部分是稍微弱一点而已，就是比绿色的弱一些。本来的话进来的时候，我们会假设这个橘色跟绿色的话是一样那么大的，各占那个 intensity 的1/2。Okay, so so here it says that as shown in the figure above, a reflected wave will be fully polarized with its E vector perpendicular to the plane of incident. if we strike a boundary at the Brewster angle theta b where theta b equals arctangent n2 over n1， n2 over n1， 这个就是所谓的 Brewster angle， 就是跟两个物质的这个 index refraction index 有关，它的比例取 arctangent， 取 arctangent。OK， 所以N1 N2 谁大谁小也无所谓，反正 arctangent 的话，它的值域是负无穷到正无穷的啊，当然它也只会正数了，所以0到正无穷是没问题的。And then it has an interesting property is that the theta b, which is the incident angle of Brewster angle, plus the refracted angle will be perfectly 90 degree. So it means this is incident angle is theta b, and then this is the refracted angle. Of course, it will also be theta b. Okay, and then this is theta out. So this is a straight line. So 180 degree here. So it means theta b plus theta out to be 90 degree, which means these two, this line, this ray and this ray will be perpendicular to each other. 就是这个反射线跟折射线会互相垂直啊，这个是可以推出来的，Okay, actually we can simply derive it. So it is like actually we have a n1 sine of theta 1 equals n2 sine of theta 2. Oh, this is the Snell's law, and then we also have Brewster angle theta b, theta 1 to be theta b to be arctangent of n2 over n1, Okay, so which means we have theta 1 or theta b here. So and then this one is n2, this one is n1, and then this is square root of n1 square plus n2 square. Like this, we have a right angle triangle like this. Okay, so here we would like to find theta 2 because we already know n1, n2, and theta 1. So sine of theta 2 will be n1 over n2 and then times sine of theta 1. Okay, here or sine of theta b. Okay, just up to you. Theta 1 is actually equal to theta b. Okay, so n1 over n2 and then times sine of theta 1 is n2 over this one. Okay, n2 over square root of n1 square plus n2 square. Okay, so n1, n2, and n2 can cancel each other. So we have n1 over square root of n1 square plus n2 square. Okay, so n1 over this square root, okay, will be n1 over this square root will be cosine of theta 1, Okay, so here we have a sine of theta 2 equals cosine of theta 1. And actually cosine of theta 1 will be sine of pi over 2 minus theta 1. Okay, so this is a trigonometry identity. Okay, 就是三角的一些行等式了。Okay, and we know that theta 1 and theta 2 are between 0 and pi over 2, 0 and 90 degree. So which means theta 2 equals pi over 2 minus theta 1. So which means theta 2, so we can write it as a theta 1 plus theta 2 is pi over 2 or 90 degree. And theta 1 is theta b, which is a Brewster angle. Theta 2 is the refracted angle, theta r, okay, equals to pi over 2 or 90 degree. So we have theta b plus theta r to be 90 degree. OK， 所以这个是所谓的 Brewster angle，Brewster angle 产生一个极化光的另外一种方式。Okay, so yeah, so finally we have two additional problem. We have two additional problem. So this is the first one. It says unpolarized light is sent into a system of three polarizing filter. Angle theta 1, theta 2, theta 3 of the polarizing direction are measured counterclockwise from the positive direction of the y-axis. They are not shown to scale. Okay, 所以这里有三个 filter 嘛。然后有 theta 1, theta 2, theta 3，是还不知道什么角度是不知道什么角度，and then angle 1 and theta 1 and theta 3 are fixed 第一个跟第三个是固定的 ，but 但是我们不知道它什么角度 ，but angle 2 can be varied 第二个是可以旋转180度的，因为360度没意思嘛，就是上下跟向下是一样的，所以只转给你看180度，虽然它90度已经有一个周期。Okay, so the intensity of the light emerging from the filter 3 as a function of theta 2, the scale of the intensity axis is not indicated. Okay, 所以这个就是画给你看这个这个输出的这个 intensity 随着这个 theta 2的改变，当然它没有告诉你这个多高，因为你知道这多高的话，你也可以反推回去，因为这里已经足够的讯息，我们知道可以求出来它们什么角度。So what percentage of the light initial intensity is transmitted by the system when theta 2 is 30 degrees? Okay. So here we know that, okay, so the first observation is that when theta 2 is 0 degree, 90 degree, 180, 0 and 180 is the same. So when theta 2 is 0 degree and 90 degree, I is 0. I equals 0 at theta 2 to be 0 degree and 90 degree, okay. Okay, it implies filter 2 is perpendicular to either of the filters when theta 2 equals 0 degree or 90 degree。好，这个意思是说，因为它一定会0的嘛，所以的话就是说，这个 filter 2等于0度或者90度的时候，它至少跟 filter 1或者至少跟 filter 3是垂直的，它才会有这个 intensity 为0的结果，在0度跟90度这两个地方。也就是说，当它为0度的时候 ，theta 1跟 theta 3至少有一个是90度，而它90度的时候 ，filter 1跟 filter 3至少有一个是0度，也就是说 filter 1跟 filter 3一个是0度，一个是90度，因为它们各占一个坑嘛，So which means we can say filter 1 and filter 3, one of it is a 0 degree, one of it is 90 degree. So we will say without loss of generality, 就是叫做不失一般性，中文叫做不失一般性的话，就是说we can say theta 1 equals 0 degree, theta 3 equals 90 degree. 那这个不失一般性的意思是，我现在是假设 theta 1等于0度 ，theta 3等于90度你不相信的话，你可以试试看 theta 1等于90度 ，theta 3等于0度，它出来的结果会一模一样。所以我们就只写一个，就是叫做 W log without loss of generality 不失一般性。 Okay, so like this. Okay, and then finally it asks you when theta 2 is 30 degree, what is the percentage of light initial intensity? Okay, so let's go through. So the IF, okay, the final. Okay, so the final, and then this is I. Okay, IF over I will be. Okay, so first will be unpolarized. So the first one will be 1/2 to I. Okay, 1/2. And then here, theta 2 is 30 degree. This is 0 degree. So we multiply it by cosine of 30 degree squared. And then theta 2 is 30 degree. Theta 3 is 90 degree. So there is a 60 degree between them. So we further multiply by cosine of 60 degree squared. And then this is nothing but 9.4%, okay, which is actually the same as the previous sample problem. Okay, so this finish off this additional example, and then we still have another one. Okay, so this one it says a certain helium-ion laser， 就是叫做氦氖镭射啊，可能高中化学课有听过吧？ OK， 氦氖镭射的话 emits a red light in a narrow band of wavelengths centered at a 632.8 nanometer and a wavelength width of 0.01 nanometer 啊，这个对你们来说可能有点奇怪啊，对你们来说有点奇怪，就是它的中文的意思是。它这个氦氖镭射产生一个红光，它的波长是中心，它的波长的中心在632.8纳米这个位置，它的宽度，波长的宽度，什么叫做波长的宽度？什么叫做波长的宽度？是0.01个纳米。OK， 它的意思是说。其实这个现实世界当中，一个很纯的一个正弦波是不存在的啊，不可能存在的。所以我们如果透过某些方式，比如说用一个叫做 Fourier transform 的东西啊，之前有稍微提过的 Fourier transform 的东西，我们可以对任何一个讯号做一个频谱分析，一个时域的讯号做一个频谱分析。Fourier transform 大概就是像x of j omega 会等于integration of xt exponential to minus j omega t dt 重复无穷到正无穷，这个就是傅里叶转换当然可能半门课会学这个东西，或者是1/3门课会学这个东西，所以我就不细说这个是什么，反正这个是一个频谱分析的一个工具，这个一个数学工具。那你做完这个之后，你理解当中这个如果是一个理想的一个正弦波，如果它真的只有一个单一频率的话，它会落在一个欧米伽0的地方，然后它就只有一根，那这里就会很长很长的一根，旁边什么都没有，这个是频率的轴。那这里的意思是说，这里欧米伽0之外，它附近还会有一些的东西啊，还会有一些东西，它会有一个峰值。那如果我们考虑一个半宽度这是这个高度的一半这个高度的一半这个是一半1/2的比如说这个是1/2的我也不知道是什么，这个是1的话，这个是1/2，这个是1/2，我就不说单倍了，反正这是 normalize 之后的这个一个峰值这个是1/2的这个宽度，我们就会叫做 delta omega delta omega， 那这个就是 delta 这个不是 omega。这不是 omega， 这个是 wavelength。那我们如果用这个c 等于 f lambda， c 等于 f lambda， c 等于 f lambda， 的话，或者是 2πc 等于 omega lambda 的话，那这个是一个常数 ，omega 跟 lambda 是反比的关系。其实我们也可以对应，如果 omega 如果是波长，如果是频率是准的话，那这个波长也会是准的 lambda 0那这个就是所谓的 lambda 0。但是实际上这个不准的时候，那这个 lambda 的话也会不准，它就会 lambda 0，然后这个是高度1这个是高度1/2的话，那这个宽度我们就叫做 delta lambda， 这个就是 delta lambda 这个就是 delta lambda， 那这个就叫半宽度。那当然你要算的话，你可以说这个是加一半，就比如说你可以透过这个波长把这个 lambda 算出来，然后加一半减一半，然后去除。Okay, so actually it asks you what is the corresponding frequency width for the emission. Okay, 因为这个波长不准的话，频率也会不准所以他就问你这个 delta lambda 是什么他就问你这个 delta lambda 是什么delta omega delta omega 是什么 ？OK， 那我们可以用这个用这个微积分的方式微积分的方式就是 F equals C over lambda。OK，C equals F lambda，so F equals C over lambda。So we can take the differentiation。OK， 去算这个微分。微分的话是 dF equals dC over lambda. C is a constant, so C just come out, and then lambda inverse. Okay, take the derivative will become negative 1 over lambda square d lambda. Okay, so this is nothing but the derivative or differentiation. Differentiation. Okay, so we will say the delta F will be C. Okay, we just take the absolute value, ignore the negative sign. C over lambda, delta lambda, so which will be 3 times 10 to the 8th power, and then this lambda is 632 times 10 to the negative 9, and then square. And then times delta lambda is this 0.01 times 10 to negative 9. Okay, so this is the wavelength width. Okay, so we have this one to be 7.49 gigahertz. Okay, gigahertz is 10 to the 9th power. Okay, so this is the delta frequency width. 但如果你觉得这个微积分觉得有点难以理解的话，你也可以尝试说，就是因为这个是中间是632.8嘛，所以你可以算出来这个点，右手边这个点的话就是632.8加1/2的0.01。然后这个点的话是632.8当然乘以10的负9次方嘛，然后632.8减去1/2乘以0.01也是 nanometer。那这两点有的话，那你带进去 C 等于 F lambda 的话，左边这一点就会跑到右手边去，右手边这一点就会跑到左手边去，因为它们是反比的嘛，大的会跑到小的，小的会跑到大的。那你算完之后减一减，当然可能跟这个会有一点差异，因为微积分嘛，它某程度上是一点点的近似，但是这个算起来比较快这个当然算起来也不慢，但是它就要显示一下用一个微积分的方式去算这个东西。